All right. Good morning, everyone. Thanks for coming. Okay, so I'm Ben Cheng. I'm a professor from the School of Engineering, and with me, I also have my colleagues To-Yan Pang. So Pang, could you wave? Yes. And we also have Asish from PCPM, and we also have I would say our magician that making all the magic happen, George Wu, our digital twin specialist. So what we do in this project is that we try to create a multi-scale urban digital twin. Now our team have been working with different industry from manufacturers that we help them to develop a 3D model of the factory floor such that they can do optimization. We also have Asish that working with different constructor that using BIMS model, the building information modeling system to look at what's inside the building. We also create 3D model for farms such that grower would know what to do with them. But then our team also see there are some pain point because each of those individual systems, they don't work with each other by default. For example, if we look at the BIMS model, we're looking at all the internal structure of a building, but it doesn't work that well when we look outside of the building. And then when we use mapping system like similar to the Google Earth type to create a 3D model of a farm, we also see that, well, we can roughly see that how the orchard look like, but it doesn't provide us with the high precision. So we need something that can merge all those systems together such that we can create something even bigger. And what we need, or what we're trying to achieve, is to create this digital twin testbed. This become an enabler, a platform such that all the other researchers can also import their 3D model and also their physics model into this, and then we can run simulation or ask a lot of what-if questions. So what do we need is that we need an open platform and open standard. So in the middle, actually, it's quite lucky, is that it's also the time when NVIDIA roll out their Omniverse platform, and that is actually one of the major driver of what all this I'm going to show you next. So I've said a lot, all right? So we're saying that we integrate things together, but how does it look like, right? So no more text, let's watch video. Right, so here we go. So in the following, I have prepared 4 clips to demonstrate what our platform can do at the moment. So what I'm trying to do is that I try to give you some information such that we can have a more very interesting discussion during the coffee break or maybe in the work group. The first part, well, we are saying that we want to model a city or maybe all the urban buildings of the things that we're going to do. And thanks a lot. So what is trying to do is that first we import all the building information. So we have the dimension of the building, the height, etc., such that we can run simulation on lighting. So we can see how the shadow casts from one building to another. Now what we're doing right here is based on the ray tracing that NVIDIA provided, such that the shadowing and also all the calculations is very realistic and close to the real thing. And that is, well, we always say that, well, that is very similar to how Google Earth is doing, right? So that is the next step. So we import the BIMS model into it such that we have a finer detail of each building. So maybe the bottom left one, thank you. So that is the next thing, right? We can import different BIMS models such that we see that not only the external, how the building look like, but we also can see the inside. So that creates some new opportunities that, well, it's like a dollhouse, but you're not playing with one single dollhouse, you're playing with the whole city of dollhouse. So you can look into each individual of them. So you can see that, well, you can actually adjust minor detail inside it. But how are we going to use it? I mentioned about we can run light simulation, isn't it? So now you can see that how the light is going inside the building, and then you can adjust the internal arrangement of your office such that you can have a maximum utilization of the sunlight, and then you can have a lot of interior design based on that. Now, it's not only about urban, we can also apply that to factory. So maybe the top right corner, right? So we can use it to adjust the layout of factory. So you can see that how you can fully utilize the space. But at the same time, you can also run simulation because, as mentioned, this is a platform not only to show a static model, but it also allows you to put in different physics equation into it such that everything would be alive. Now then the next thing. Next one, the bottom right one, is a very interesting application. Now, if we put all this together, we can start seeing that there will be a new application. One of our potential client, or very first client of this platform is that they want to use it to create evidence to convince council about how much can they chop that tree in front of their building. So, let me tell you the story. So, there's someone owning a house. In front of the house, they've got 3 pine trees. The tree is a little bit too tall and it's blocking the sunlight, so they want to chop it down a little bit. Okay, the neighbor against it, right, saying that you shouldn't, right? It's going to damage the scene. So the question is that if they really have to chop, how much should they chop? So the model like this would allow them to find out the answer, because by chopping the tree in the 3D model, we can quickly run simulation to see that how sunlight is getting into the building, such that we can, find out what is ideal length. So this would be something that council can use to resolve conflict between residents. And then in the future, in the future, we can also see that solar panel, right? So we all love to install solar panel on our rooftop, but if there's a building in front of you that is blocking most of the sunlight, then you will not be happy about that. So model like this would allow us to do that. So maybe next slide. I just quickly mentioned about solar panel. So this is something that we can also do. We can use it to study how to control solar panel in a solar farm or in an actual farm with agri-voltaic technology. And furthermore, the one at the bottom right, we can also use the same model to train robot, because now we can adjust the lighting condition, from night to day, day to night, very quickly. And that is not only applicable to a farm, but you can also apply it to any indoor building, because right now you have both the external information and also the internal information of the whole building and also the city around that. So last one, really last one, I promise, right? Last slide. So the question is that how good it is now. So I showed that a lot of things happen. So I think, so this is something that happened. We tried to create some LinkedIn posts to demonstrate what we have done. Because we based on Omniverse, NVIDIA Omniverse, we also tag NVIDIA, of course. And then surprise, that some people, some interesting people actually like our post. So they are the Vice President of NVIDIA Physics AI Simulation and Omniverse Performance, and also the Director of the Next Gen Real-Time Photorealistic Path Tracing of NVIDIA. So I think that really is saying something. But no, I'm not bragging about this. What I want to do is that I want to create a new opportunity. Our team. So feel free to reach out to us during the coffee break. If you have an idea, you have data that you want to use this technology, we are happy to help. We hope that we will be part of your journey. Okay, thank you. Thanks.